Hi, 7th grade. What I want you to do is go back in your book, in your journal, and go back to the page where we talked about theoretical probability, and it was directly opposite the pink foldable that we did, okay? So the one thing that theoretical probability was is that it should happen, technically, right? We have another one called experimental probability. You guessed it, we're going to actually do the experiment. Okay? So in an experimental probability, this is what actually happened. Oops, sorry, actually. Okay? So for example, in this first sheet, what they did, this is the worksheet that we're going to do in just a second, but they actually pulled some cards. So technically, the experiment is actually what actually happened, and here's the documentation of it, okay? So what we're going to be getting into, and I don't want to go too much into detail here because in the next, today and tomorrow, we're going to actually do some experiments, okay? And then what we're going to do is compare the experimental probability with the theoretical, and you're going to notice something that starts to happen, okay? So go ahead and close your journal. I don't want to spend too much time on that. And what I want to do is go ahead and get this out, and what I'm going to do is walk you through all this. I have attached a video that explains a deck of cards, so if you are not familiar with a deck of cards, I need you to watch that before you do this, just so you can understand, okay? So what you have here is experimental and theoretical, so we're probably going to be comparing the two. If Amanda used a standard deck of 52 cards and selected a card at random, she recorded the suit, and a suit is the image that you see here, okay? You have a spade, sorry I didn't have, you have a club, a heart, and a diamond, okay? So there are 4 different suits. So she recorded the suit of the card that she picked, and then she replaced the card. So we have with replacement, we're not going to have to change the outcome of the second event, okay? You know, when we subtracted one from the denominator, we're not going to have to do that here because she replaced the card. The results are in the table below. So based on her results, what is the experimental probability of selecting a heart? So we're not looking at theoretical, we're actually looking at, so first we need to find out the total, right? In theoretical probability, our total is 52. But how many times did she actually pull the card? So you have 5, 10, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So in other words, she did the experiment 30 times. So the number of trials in experiment. Okay? So based on her results, what is the experimental probability of selecting a heart? So I know my bottom number is going to be a 30, and my top number is going to be actually what happened. So the heart is 5, 6, 7, 8, and 9. And that's your answer. Okay? What is the theoretical probability of selecting a heart? So we know, if you weren't familiar with cards, I did want you to watch the video that I attached. We know that there are a total of 52 cards, and there are 4 suits. So if I divide 42 by 4, I get 13. Okay? And if I reduce that and I divide both numbers by 13, I'm going to get 1 out of 4. Okay? All right, so based on her results, and remember, when I did that, I divided by 13, okay, to reduce to get a simplified fraction. So based on her results, what is the experimental probability of selecting a diamond or a spade? So we know that there was, in the experiment, because that's what we're talking about, your bottom number is a 30. Now they want to know whether it was a diamond or a spade. So am I going to add the two? Yeah, because it doesn't matter if I pick a diamond or a spade. Okay, so I'm going to add those two. So 5, 6, 7. Add 10 is 27. Yep, you caught me. 7 plus 10 is 17, plus 1 is 18. And your numerator is going to be an 18. Okay? And if I reduce that, I can divide by 2. Would give me 9/15. And it looks like I had a greater common factor, didn't I? I could have done 6. But it's okay to start with small numbers if you know that it's divisible. I know some of you, the greatest common factor was 6. So here again, I can divide by 3 again. And that gives me 3/5. And so what that means is out of the experiment, out of every 5 cards, 3 of them were either a spade or a diamond. Okay? Is it kind of close to half? Doesn't look like my experiment was that long, was it? Because I didn't really use a full deck of cards. And technically, half of the deck should be diamonds and spades. Okay? But it looks like out of my experiment, the greater probability was given to diamonds and spades. So what is the, number 4, what is the theoretical probability of selecting a diamond or a spade? So now we want to do, and just like we said, there are 13 in each suit, so a possibility of 26 cards out of 52, or 1/2, should have been for a diamond or a spade. They want you to compare these results, and it looks like I already did that for you. We know that 3/5 is greater than 1/2. Okay? So that means that my experiment favored diamonds and spades. Okay. So Dale, I'm sorry, we're going to move on to this one right here. I kind of want to do, I'm going to do one more with you, and then I want you to do, that one on the back is a little tough. Let's just do this one. Okay. So Dale conducted a survey of the students in his classes to observe the distribution of eye color. The table shows the results of his survey. Okay? So remember that when we always do an experiment, we always need to find the total. We need to find the total of number of trials. So 58 plus 12 is going to give me 70. And I'm going to combine that 8 and 2 is another 10, so 70 and 10 is 80. We had a total trial of 80. So find the experimental probability distribution for each color. So what was the probability of a blue? 12 out of 80. Can we reduce that? Absolutely. Can we start with 2? I think we can go more. What about 4? Absolutely. So if we divide both by 4, that gives me 12 divided by 4 is 3. 80 divided by 4, that's right, is 20. So every 3 out of 20, if I did 20 trials, because this is reduced, these are my odds, is what my experiment. Because technically, actually, they just did students. Let's see. Oh, my bad. Okay, so brown eyes would be 58. My phone is going off the... And 80. Can we divide by 2? Sure. Give us 29 divided by 2. So we have 29, and then we have 40. A little bit closer. Actually, it's definitely favors brown eyes. And green would be 2 out of 80, and that is 1 out of 40. So not a lot of people have green eyes, okay? And then hazel was 8 out of 80. And if we reduce that, we divide by 8, giving us 1/10. Okay? Now, based on this survey, what is the experimental probability that a student in Dale's class has blue or green eyes? We combine those. So 14 out of 80. And you're going to reduce that. Or simplify, sorry. So divide by 2. When in doubt, if they're both even, divide by 2. So 7 out of 40. Based on the survey, what is the experimental probability that a student in Dale's class does not, here's the key, does not have green or hazel eyes? That's right. So we're going to eliminate the green and hazel, and what are we going to do? We're going to add the blue and brown because I do not want green or hazel. So 12 and 58 is 70 divided by 80. And remember that when you have a number with 2 zeros at the end, you can divide by 10, which eliminates those zeros. Okay? So if the distribution of eye color in Dale's grade is similar to the distribution in his classes, about how many of the 360 students in his grade would be expected to have brown eyes? This is a direct proportion, okay? So the beauty of an experiment is we can actually use it for prediction, and the tic-tac-toe is going to help us here. So we always have a ratio right here and another ratio right here. And we're going to prediction, and this is our experiment. Oh, the other way around. Oops, what was I doing? So total students. We know, and I apologize, I was just now looking at this, the number 1, we're going to use our experiment. So the experiment for, let's see, brown eyes is going to be 58 out of our total, which is 80. Okay, so I apologize. So you always have your total, and this is going to be your part. Okay. Now, in the second one, they want to know out of 360 students. And I'm looking for how many students. Yeah, I'm finding that unit rate, aren't I? So I can divide both by 0, or divide by 10, sorry. And if you notice, do I have another common denominator? I could do 4. Okay, let's make our number smaller. So 8 divided by 4 gives me 2. 36 divided by 4 gives me 9. I can even do this right here. So 2 divided by 2 is 1. 58 divided by 2 is 29. So my answer is going to be 29 times 9. 9 times 9 is 81. Carry your 8. 9 times 2 is 18. Plus 8 is 261. So 261 students, and I'm sorry, I'm off, have brown eyes. Okay? All right, on the back, I want you to try your best. What I want you to do, we're actually going to put this in our journal tomorrow. I'm going to let you do this by yourself. Seek out a teacher if you don't understand. Any of the teachers can help you. And I will see you tomorrow. Do not forget to complete the puzzle about the actor. Remember the question about Times Square? And I will see you tomorrow. Bye.